Laura. Laura. So, yeah. So they put in terms of the people with 90 and above. So we had 8 students. Then B is this one is 80 and above. So we had 10 students. And then C below 80 to 70 or 69. So let's say from 69 up to 79. This one was C. So C, we had like 2 students, and then the rest of failed. Maybe some of them did not do the exam. So if you feel like you still want to redo the test, then you can do it. I can give you like up to midnight to submit. Okay. If you feel like you did not do well in your test, so just do it. Submit before midnight. If you're having, especially those people who are having below 80. So if you have below 80, you can redo your test, then you send it to me. Maybe I can grade it and then I can give you some extra credits. All right. Okay, so that's how our exam will be. So exam 3 will be like that, we'll be doing like that. I don't know how the final exam will be done, but I heard we'll be doing through the Newton. So I think it's through the Newton. So yeah, I'm not that sure, but we'll be told at the end of this, before the end of the semester. So I think the exam was fair, right? Everything which was there, we covered. Again, please make sure you do your quiz and your homeworks. 1 point will add to your credit. If you miss a quiz, if you miss your homework, if you miss your exam, you're reducing your credits. You're reducing your marks. So make sure you go back to from section 2.5 to the end. Do them. Make sure you do all of them. All right? Do everything. Don't leave anything. Please do everything. I don't want you guys to fail at the end of the semester. And I don't want anyone to be having 89, and 89 is like B plus, right? So if you get 90, that one is A minus. I don't want anyone to be having like 92, instead of getting 93 to get an A, you will get a A minus. So if you do everything, then you will get the extra credits. So everything adds. So make sure you still read the syllabus, because I think most of you've never read it. If you miss an exam, because I think it's always there. If you miss an exam, then there is no makeup, unless you explain to me why you missed the exam. If you miss a quiz, then there is no makeup, unless you tell me why you missed the quiz. All right, so also if you look at Moodle, at the end of your what you're getting, like the marks, there is a course total. And I think you can see it from there. So you can see what the accumulation of what you've gotten from doing the homeworks, the quiz, and the exam, and the assignments. You will see it over there. So you will know what you will get at the end of the semester.
So if we got a good score on the first test, but if we wanted to retake it, would you take the better?
Because the first test was okay to most of the people. But if you still want to do it, you can do it, because I already sent the solution, right?
Yeah, the first test.
The first test. So the second test, you can redo it. If you feel like you not perform well, you can redo it, and then you send it to me before I send the solution manual. All right? Is that okay?
Yeah, so you'll take the better if you score.
I will see what I will do.
Okay.
So if you have less than 80, then I might mark it out of 80%. Okay? So if you get 100, that one will get 80. I need to be fair to everyone. All right? Did you get my point? If let's say you have 62 in exam 2, because I want most of you to be above 80, so I'll mark it out of 80. All right? Am I clear on that? I want to be fair to everyone. I cannot give you 100 and it's like you're retaking the exam. I cannot do something. It will not be fair. Okay? So I will mark it out of 80, like 80%. If you get 100, that one is 80%. Okay? So I want to be fair to everyone. So please redo it if you feel like you did not do well, and make sure, I always insist, make sure you do the quiz, the homeworks, and everything. Make sure you do that. The quiz, I think it's 30%. I'm not that sure of the final score, or 20%, something like that. And the homeworks is there. I know the exam is 25% of the final grade. So the other ones are the homework, the quiz, and any activity that we do. Any question? Are you satisfied?
Yeah, so basically you're saying if you got over 80, just don't retake it.
If you feel like retaking it, I will see what I will. Okay? Because of course you've done something, so I'll give you some extra credit somewhere. Yeah. But basically, I'm trying to help those people who are having below 80. Okay? All right, so if you have any question, you can even write a mail to me, and then I can explain more on that. All right, so any other question? All right, so let's do section section 8.2. Section 8.2. So this is a continuation of section 8.1. So section 8.2 is dealing with simplify radical expression. Simplify the radical expression. So here we're going to look at the product property, and number two, the quotient property. The product property and the quotient property. So let's start from the product property. The product property. So of course, we are looking at the product property of the roots. The product property of the roots. Now, if we have the nth root of A times B, the nth root of A times B, where n is greater or equals to 2, where n is greater or equals to 2, then we can still write this as the nth root of A times B is equals to the nth root of A times the nth root of B. The nth root of A times the nth root of B. So in this case, we are trying to simplify this, the product of A times B. So we need to remove the radicals there. So we need to simplify A to the point where we cannot simplify it again. It becomes sad. We need to simplify B to the point we cannot simplify it again. For example, if we are given the square root of 500, the square root of 500. So here, first of all, you can look for the fact. So this is the same as well. This is 2, but it's always higher. 500, right? So this n is greater or equals to 2. So it's equals to 2. So what we do here, we need to get the factors of 500. The factors of 500 to the point that we can be able to get the square root of it. Okay? So we need to look for the factors which can cancel with this square root here. So what are those factors? Like if we have 500, then we can divide by 2, right? Or we can divide by 100, right? So if you say 100 and 500 there, what remains is 5 over there, right? And this 100, so it's the same as 100 times what? Times 5, the squares. Okay? So this is like A, and this one is like B. So here we can get using the product property, which is this. Then here it can be the square root of 100 times the what? The square root of 5, right? Again, looking at this, okay? So the 100 here is the same as what? So this is the same as the square root of 10 raised to what? 2, right? Same as what? The square root of 5. Again, we are able to, using what we did on last week. So here we can get the what? The square root, okay? So what is the square root of 10 raised to 2? It is what? It is 10, right? Because we multiply by half here. So we get 10 and then multiply. Can we get the square root of 5? We cannot. So we multiply by 5. So we can, and that is our final answer. So this, we have simplified this one completely. So simplified completely. So I have some of the examples which I posted in Moodle. Again, if you still remember, if it is an even, if we're getting this, let's say the square root of 4. The square root of 4, because we are doing it for the even number, then what do we get? We take the what? The absolute value. So again, here, what we do is we get the absolute value of 10. Absolute value of 10, and then the root of 5. Please don't forget, because the square root of 10 can be plus or minus 10. Okay? The square root of 10 raised to 2 can be plus or minus 10. So what we are doing, we are checking the absolute value of that. So absolute value. So our answer is absolute value of 10, and then the root of 5. Absolute value of 10, the root of 5. So I have some of the examples which I posted in Moodle. So example number 1 is over there. So the square root of c raised to 11. The square root of c raised to 11. So how can we write this one in terms of the product property? So we can write this as the square root of c raised to 10 times this. Times what? Let me see. So we are trying to, because this is raised to 2, we are trying to look for a number, the radical there, the power, which can be divisible by 2, okay? We're trying to look for something which, a number there on the power, which can be divided by 2. Now, using the product property, then this is equals to the square root of c raised to 10 times the square root of what? Times the square root of c. So again, we cannot have the square root of what? C, right? So it will just remain like that. But here, we can get the square root of c raised to 10. So I say, if it is a square root, then if it is a square root of, let's say square root of a. So this is the same as a raised to what? 1 over 2. You still remember that? So again, here, what will be our answer here? It will be c raised to what? C raised to 5. So finally, what we get is, because I said, because it's even, then we need to put the absolute value and then c raised to 5 there. And then times what? The square root of c. And that is our final answer. Okay, another example is example number 2 there. There's cube roots of negative 128. The cube root of negative 128. Now, do we have the square root here, the cube root here? Are we getting the real number when we get the cube root of negative number? Yes, right? Because I said also that you have, let's say, negative 1 cube. This is equals to negative 1, right? Because this is like negative 1 times negative 1 times what? Negative 1. So this will multiply with this. So it will be positive. What remains is the negative. So it will equal to negative 1. Okay. Now, when we get the cube root of negative 1, what are we getting? What is the cube root of negative 1? It is negative 1, right? But when you're given the square root of negative 1, this is what? This is a complex number. We are not getting that. So this is a complex number, which we will do it next time. So we don't have the, so we just put the empty there. So if you've done your homework, then I think there's some questions where they're asking you for something like that. So what you only put there is what? Empty. So there is no solution there. Now, when we come back here, the cube root of 128, we can write using the product property. Then we can write this one as the cube root of, let's say, negative 1 there. And what? The cube root of what? 128. So use like that. So the cube root of negative 1 there, and the cube root of 128. So basically, we can use the same product property. We can see right as the cube root of negative 1 times the what? The cube root of 128. Cube root of 128. Okay. So what do you get? So when we get the cube root of negative 1, what are we getting? Negative 1, right? So we get negative 1. Now we need to solve it. So we need to get the factors of 128. The factors of 128. So let's come here. So we have 128. So 128, when you start by dividing by 2, what do you get? 61. 64, right? And then 2, what do you get? 32. 2, you get what? 16. 2, you get 8. And then 2 again, continues like that. So these are how many 2s? How many 2s should we get to get 128? 1, 2, 3, 4, 5. 6 or 7? So 2 raised to 7, right? So 2 raised to 7. Now, so we have the cube root of 2 raised to 7. Now, what should you do there again so that this power, we get a power which can be divided by 3. So how should we write this? So we can write this again by, so don't leave this one. So we have negative 1 there. Then we can still write this as the cube root of 2 raised to 6 times 2, right? Because the bases are the same here. So what do you do to the power? You add. So when you add the powers, you get what? 2 raised to 7. So you get 2 raised to 7. So coming to the next step, using the same product property here. So we still have -1 outside, and then we have the cube root of 2 raised to 6, times the cube root of 2. The cube root of 2 raised to 6 times the cube root of 2. Okay, so this cube root of 2 raised to 6, what will you get? So if you divide by 3, what will you get? You get what? 2, right? So we have -1, and then 2 raised to 2 times the cube root of 3. The cube root of 2. So finally, our final answer will be what? -4, and then the cube root of 2. So this is our final solution. -4, then the cube root of 2. Are we together? So that's how you solve. That's how you use the product property. Okay, there is another example over there, but I know you will go through it. So let's come to the quotient property. So let's come to the quotient property. Of roots. Quotient property of roots. Now, like the product property. So if the cube root, let's say the nth root of A all over B, if we have the nth root of A all over B, where n is greater or equals to 0, is greater or equals to 2. Greater or equals to 2. And this B here, and B is not equals to 0. The B is not equals to 0. Then we can write this as then the cube root nth root of A all over B is the same as the nth root of A all over the nth root of B. The nth root of A all over nth root of B. Again, the nth root of A all over the nth root of B is the same as the nth root of A all over B. Nth root of A all over B. Now, if the bases are the same and you're given, let's say, A all over M all over A all over B all over N, something like that. Then if this is, let's say, the B root of that. So first of all, what you do, you can simplify the one which is inside here. So we can simplify this by doing what? So since the bases are the same, then because this is a quotient, what do you do to the power? We subtract, right? So this is similar to the b root of a m minus what? M minus f. The b root of a m minus f. All right, I have an example here. Example. So example. So if you have the cube root of 625 u raised to 5 all over v raised to 12. The cube root of 625 u raised to 5 all over v raised to 12. Now, here, using the quotient property, so we can write this as the cube root of 625 u raised to what? 5 all over the cube root of what? V raised to 12. The cube root of v raised to 12. Now, the numerator and the denominator. So looking at the numerator, then we can use the product property in the numerator. So in the numerator, then 625 is similar to what? If you get a factors. 625 is similar to 5 raised to what? 3, right? Right? So 5 times 5 times 5. Is it 5 raised to 3 or 5 raised to 4? No, 5 raised to 4. So because it's 625 is 25 times 25, right? So 5 raised to 4. So 5 raised to 4, and then this is u raised to 5, the cube root of that, all over the cube root of v raised to 12. The cube root of v raised to 12. So we can also write this as this 5 raised to 4 can be written as, so the cube root of 5 raised to 3 times 5 raised to 1. And this u here can be written as u raised to what? U raised to 3, u raised to 2. Then all over. Because, oh, this one was cube. Because this is 12, and 12 can be divided by 3 here. So 12 can be divided by 3. Then what would be our v then? So it would be v raised to 1. V raised to 4. Because this 12 here, when you divide by 3, you get what? 4. Okay. Now, when you use the product property here, above here, so which one can be divided by 3? So we have the 5, we have the u raised to 3 there. And then the other ones will not be simplified further. So what we get is what will remain here will be what? 5, right? So we have the 5. And then this u here, when you cancel by 3, you get what? U there. And then this will still remain the cube root of 5, and then the cube root of u raised to 2 all over v raised to 4. So finally, this, we can combine this one. So finally what we get is 5u, and then the cube root of what? 5u square all over v raised to 4. And over v raised to 4. So this is the further we can simplify that. Okay, so another example. This 7th root of n raised to 26 all over n raised to 3. N raised to 26 all over n raised to 3. So when we were studying the quotient property, I said if the bases are the same here, so what you do first, you simplify the inside. So to simplify what is inside here, then what do you get? The 7th root of what? N raised to 26 minus what? Minus 3. N raised to 26 minus 3. So what you get is the 7th root of n raised to what? 21. 23. The 7th root of n raised to 23. Now, using the product property, then we can write this as the 7th root of what? N raised to 21. So n raised to 21 times the n raised to what? What will remain from 21? 2. Because 21 can be divided by 7, right? Right? And then 21 plus 2 is equals to 23. So finally, canceling the powers there. So what do we get? So because this one is odd, then definitely we don't need to use the absolute value. So we get n raised to what? 3. And then the 7th root of what? N squared. That is our final answer there. That is our final answer. So similarly, we have another example, which is the c raised to 4 all over c raised to 16, the square root of c raised to 4 divided by c raised to 16. So c raised to 4 all over c raised to 16. Now using the same step, then this is similar to square root of c raised to 4 minus what? Minus 16. So step number 2 is the square root of c raised to what? Minus what? Minus 12. C raised to minus 12. Now, how can we write that? So this is similar to the square root of what? 1 all over c raised to 12. Is similar to that. Now, since this can be divided by 2, or we can write this as still write this one as the square root of 1 all over C6, and then raised to what? Raised to 2. C6 raised to 2, because C6 times 2 is C1, C12. So these two can cancel with a square root there. So finally, what we get is 1 all over C raised to 1, 6. Now, since the power or the root is even, then we need to put the what? The absolute value there. So you need to put the absolute value here. So it will be 1 all over the absolute value of C raised to 6. C raised to 6. Do you have any question? Values. Ashley. Victoria. Rachel. Laura. Adam. Vehi. Andrew. Destiny. All. Abby. Aliyah. Aldo. Jillian. Martinez. Remington. Meaton. Rayleigh. Eric. Taylor. Relay. Rock. Eden. Samuel. William. Walkman. All right, see you guys on Wednesday.